Good afternoon, all. Bill Thomason here, November 6th, November Bravo, November, broadcasting from Mercer Island, Washington. Let's do technician section 4 today, A and B. Only 2 questions from these 2 sections are going to be on your test, but there's a couple dozen possible questions, so we're going to go over them. Steve, I am not able to share screen right now.
Ray, can you fix that?
Or Ray, I should say, yeah.
Okay, is the second time the charm?
Let's see. It looks like it's going to work this time. Yeah. Okay. Best practices in amateur radio technician license class. We're going to get right into it. So 2 topics, 24 questions in this pool. 2 questions will be on your exam. T4A is all about station setup, connecting microphones, reducing unwanted emissions, power source, connecting a computer, radio frequency grounding, connecting digital equipment, and connecting an SWR meter. Let's get into it. Okay. Question 1. What must be considered to determine the minimum current capacity needed for a transceiver power supply? Let's see, efficiency of the transmitter at full power output, receiver and control circuit power, power supply regulation, and heat dissipation. I would say all of those are correct. Let's see if I got it right. Yes. That is one of those where all of the choices are correct. Minimum current capacity. Question 2. How might a computer be used as part of an amateur radio station? Logging contacts and contact information, sending or receiving CW, also known as Morse code, for generating and decoding digital signals. Again, all of these choices are correct. Computer is very useful in a ham shack. Okay, question 3. Why should wiring between the power source and the radio be heavy gauge wire and kept as short as possible? A, to avoid voltage falling below that needed for proper operation. B, to provide a good counterpoise for the antenna. C, to avoid RF interference. In this case, D is not right. The correct answer is to have your voltage stay up to what the radio expects. If your cables are too thin and or too long, there will be a voltage drop, especially if you're running from a battery. And none of these are going to take that long. So please raise questions. If I'm not responding to something, because right now I can't see the chat window, somebody please alert me if there's a question. We have time for questions. Question 4. Which computer sound card port is connected to a transceiver's headphone or speaker output for operating digital modes? This is very important. Hooking the computer to the radio has to be very particular. So where on the computer is it going to be connected? If it's coming out of the radio, that means it's going to go into the computer. So the correct answer is C, the microphone or line input to the computer's sound card. This is often an external sound card. Some computers you can do it with the internal, but not always a good idea. Microphone or line input. Question 5. What is the proper location for an external SWR meter? SWR, as you may or may not know, means standing wave reflection, right, Steve? SWR, standing wave reflection.
Ratio.
Ratio, thank you. See, that's why I asked. So where does it go? How do we use that meter to see how we're doing on getting power from the transmitter to the antenna? Well, it needs to be between the transmitter and the antenna for it to work. So in this case, the answer is A, in series with the feed line, meaning the antenna cable, coax cable between the transmitter and the antenna. Definitely not B or C or D. Question 6. Which of the following connections might be used between a voice transceiver and a computer for digital operation? Let's see. Receive and transmit mode, status, and location. Antenna and RF power. Receive audio, transmit audio, and push to talk. Or NMEA, GPS location, and DC power. Well, generally, we want the computer to be able to make like it's operating the radio. So it needs to hear what the radio is doing. It needs to be able to put audio through the radio, and it needs to be able to tell the radio when to transmit. So the correct answer is C. The three things that need to be connected between the computer and the radio are receive audio, transmit audio, and push to talk. In other words, the computer has to be able to make the radio transmit when it's time to transmit. Question 7. More about computers and sound cards. How is a computer sound card used when conducting digital communications? The sound card communicates between the computer CPU and the video display. Don't think so. Sound card records the audio frequency for video display. No. The sound card provides audio to the radio's microphone input and converts received audio to digital form. That sounds a lot more likely. And in fact, that is correct. But if you think about what they're asking, that's pretty easy to spot that one. Definitely not involving the video display. Question 8. Which of the following conductors provides the lowest impedance to radio frequency signals? This one I didn't get right when I first done, and I'm not surprised. Round stranded wire, round copper clad steel wire, twisted pair cable, or flat strap. Which is the lowest impedance, meaning resistance? Turns out flat strap, which is why they're very popular for grounding equipment, because they're super good at conducting electricity that's unwanted to your ground. Question 9. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? A bandpass filter, a low-pass filter, a preamplifier, or a ferrite choke? It's actually a ferrite choke. That's a little donut-shaped gadget that you wrap a few turns of the microphone cable through that removes some of the interference from radio frequencies. See if I can find a picture of that. Yeah, they come in all kinds of shapes and sizes. Do you guys see these? Let me make sure I am. Can you see my Google search? Okay, everybody?
Yes, we are seeing it.
Okay, great. So there's some that you can just clamp onto a cable. There's some fancy ones. Some examples of how they might be used. That's the cool thing about the internet. Once you know what something is called, you can find out a lot about it pretty fast. Okay, question 10. What is the source of a high-pitched whine that varies with engine speed in a mobile transceiver's receive audio? Sometimes you'll hear this when somebody's driving around and transmitting on the radio, and you'll hear this up and down whiny background sound. And it turns out it's coming from the alternator. So as the engine goes faster, the pitch goes up. And that's the clue that everybody will hear on the radio. So it's not the ignition system. It's not the electric fuel pump. It's not the anti-lock braking system. It is the alternator. And finally, question 11. Where should the negative return connection of a mobile transceiver's power cable be connected? Your radio's got red and black wires coming out of it. They need to get power from someplace reliable. If you're installing in a vehicle, you don't want to put that in the cigarette lighter jack. You will burn out your cigarette lighter. You want the most reliable power source, and that's the actual battery in your car. So the best place to connect the black cable, the negative cable, is right at the battery or the engine block ground strap that the negative side of the battery is connected to the body of the car. You're almost on the battery at that point. So definitely not the antenna mount, not any other metal part of the vehicle, or through the transceiver's mounting bracket. Right to the battery, or at least the engine block strap. And I see something in chat. Yes, we see. Thank you very much for the response. Any questions about any of the T4 Section A points? I went through them fairly quickly with no great explanation. I'm up for questions always. Otherwise, I'm going to go into Section B. Okay, more best practices. Amateur radio practices and station setup. Operating controls, here we go. So things like tuning, use of filters, squelch function, AGC, which is automatic gain control, transceiver operation, and memory channels. Okay, question 1. What may happen if a transmitter is operated with the microphone gain set too high? In other words, the microphone is too sensitive. The radio has been set possibly accidentally. Somebody like me with a booming voice, I generally have to turn my microphone gain down or have the microphone several inches away from my face. So what could happen if you transmit with the gain set too high? It's going to distort the output signal. People say, Bill, you're too hot. Back off the mic. Hot meaning you're distorting your voice. It doesn't have anything to do with the output power or the frequency varying or increasing SWR. It's that you're probably distorting your own voice. Question 2. Which of the following can be used to enter the operating frequency on a modern transceiver? The cool thing about most modern radios, whether VHF, UHF, or HF, or an all-mode radio, is that they all have some kind of digital pad. So you don't have to use the knob necessarily to put in the frequency, which could take a lot of dialing. You can also enter on most radios, you can enter using the keypad. So the answer is A, the keypad or the VFO knob. VFO is variable frequency oscillator. So it's not CTCSS or DTMF. It's not the automatic frequency control. It's definitely not all choices. It's either the keypad or the knob can enter a frequency. Question 3. Oh, one of my favorite controls, makes things quiet. What is the purpose of the squelch control on a transceiver? Set the volume? No. Set the transmitter power level? No. Adjust automatic gain control? No. It's to mute the receiver output noise when no signal is being received. You don't want to listen to static all the time. So you set the squelch just high enough that you don't hear anything until somebody transmits. And sometimes if you're in a high noise area, you might have to temporarily increase it, but you don't want to increase it to the point that you don't hear anything. So finding that threshold where it breaks and just past the point where it gets quiet is usually where you want to set your squelch. Question 4. What is a way to enable quick access to a favorite frequency on your transceiver? Enable the CTCSS tones? No, that's not it. Store the frequency in a memory channel. Ooh, that sounds pretty good. Disable the CTSS tones? Nope. Use the scan mode? Nope. It's definitely B. Most radios these days have memory channels. So you got a favorite frequency, especially if it's a repeater, you want to set not only the frequency, but the transmit offset and the tone that the repeater is expecting. And all of those things will be stored in memory. And you put your favorites in memory channels so you don't have to remember any of that stuff. The radio does. Question 5. Which of the following would reduce ignition interference to a receiver? Changing frequency slightly, decrease the squelch setting, turn on the noise blanker, use the RIT control. I had to look that one up. It's the receiver incremental tuning control. Let's see if I saved that in my search. I did. Except that one didn't have a very good explanation.
It's too hard.
So basically, it lets you make very small adjustments to the receiver frequency. Let me go back to my.
Hi, Buster. Why are you growling at me, Buster?
I'm listening to somebody talking about growling. So in this case, in fact, the next question talks about what the. Oh, that's still not right.
Bill, I have a question in chat.
Yes, sir.
It says, what chapter in the book are we on?
Well, that's a
We're not-
great question. I don't have the book in front of me.
Since we're not going by the book per se, we're going by modules in the exam pool. So we're in, as he has got up on the screen, technician 4 was the first two digits there, that T4B05, and I'm hearing an echo, and I don't think that's me.
And I don't recall, I'm sorry to say, exactly which book we're using for this class, if any. Steve or Ray, do we have an official book for this class?
No official book. We've suggested a couple of things to people
Okay.
that they might use for study material.
Okay. So what I found here about the RIT control was not the right answer. The right answer is turn on the noise blanker. So that would be reduce ignition interference to a receiver. But the RIT control does come up in the next question. Which of the following controls could be used if the voice pitch of a single sideband signal seems too high or low? This one is the clarifier. The, again, receiver incremental tuner is kind of it's a fine-tuned control that lets you tweak the receiver frequency without necessarily changing your transmit frequency. And Steve gave a comment in the chat that said many radios also have an XIT, which is the transmit incremental tuner. Again, you can slightly change the transmit frequency without changing your receive frequency. And let's see if I'm
So Bill, that didn't advance.
okay.
And I see that you have brought up Wave Talkers on Technician 2018 to 2022.
I see that.
And we have the question in chat that the questions don't match. And I would think that's
Okay.
probably the case.
I think Wave Talkers is behind, and I need a different set of T4 questions. So let me unshare for a second here and find my, I did open a Word file that is supposedly current. Let's see if I can. We're down into T4B. So let me try sharing again. And this time here. Okay. This is the latest list, supposedly. So this isn't going to help us with the right answers, but at least we'll get the right questions. So, section B1, what is the effect of excessive microphone gain on single sideband transmissions? Frequency instability, distorted transmit audio, increased standing wave ratio. I don't know. Anybody know the answer to this one?
You already talked about it when you mentioned hot microphone.
Is this the same subject? I'm not sure that's the case. Talking about excessive microphone gain on SSB transmissions. That's AM. I think you're right, though. I think a distorted transmit audio is the correct answer. But let me double check that. Because I don't want to give wrong answers. I don't know the
I
answers.
think the answers are in the paren section there.
Yeah, after the question number, it gives you the right answer. So it's a dead giveaway there. And what we
I'm
might
sorry,
want to
where do
do,
you see that?
you have T4B01 and then
Oh,
B
the
in
answer is B.
parentheses. Yeah, and so that's going to be the case on all of them. And I
Okay.
think what we need to do is explain why.
Okay. You mean why it's a distorted transmitted audio?
Well, yeah, you can tell them that it's distorted transmitter audio, but the question is why, and you gave that answer earlier with regard to having a hot mic.
Yeah, that is definitely still the case. Okay, so we did 2, that's the same. We've got here's another question about squelch. So this is another way to look at squelch. Question 3. If you're trying to hear a weak signal, you do have to back off from the silence because your squelch is probably set too high to hear a weak signal. So you temporarily turn your squelch down so you can start hearing static, and then maybe you'll hear, especially if you're on simplex, you're not listening to a repeater, you're trying to hear somebody, maybe they're using a handy talkie and they're on the same frequency as you, and it's not a very strong signal. So you might have to turn your squelch down. Okay. The correct answer on that one is A. All right, question 4. We already did that, stored in memory channel. Question 5, we didn't do scanning yet. The idea of that many radios, you can sell it to scan between an upper and lower frequency, and it'll stop if it hears something. And so if you're not sure what to listen to, you can listen to a range, and it will automatically tune up and down through that range and stop if it gets a signal. And again, the squelch setting would be important. If you have it too high, it may not stop at all. Question 6. We already touched on that, the receiver incremental tuning, or it's also called a clarifier, I believe, on Yaesu radios. Here's a good one. Question 7. What does a DMR code plug contain? DMR is digital mobile radio, right? Or is it digital mode radio? No, mobile, digital mobile
Mobile.
radio. Yeah, it's open source digital radio, which many of us are getting into these days. In this case, the code plug is a chunk of information that can be loaded into your DMR radio from your computer, and it programs a number of channels for you. This is great if you're in a group like I am in Seattle, where we're starting to experiment with DMR, and the people that are very good about leading our group came up with a code plug that was fairly representative of our available repeaters and talk groups in our area. And so all I had to do, being a lazy person, was copy that code plug and learn how to put it into my radio. So the correct answer is B. The code plug contains access information for repeaters and talk groups in your area. Question 8. What is the advantage of having multiple receive bandwidth choices on a multimode transceiver? Monitoring several modes? Nope. Permits noise interference reduction is the correct answer by selecting a bandwidth matching the mode. And we're going to get into some more questions about that lower down. Definitely doesn't have anything to do with the number of frequencies in memory or the offset between receive and transmit frequencies. Question 9. How is a specific group of stations selected on a digital voice transceiver? Specific group of stations selected on a digital voice transceiver. Entering the group's identification code. I don't understand this one, Steve. Do you understand this question?
Sorry, I was going back and checking the roll. Which one you on?
I'm on B09. How is a specific group of stations selected on a digital voice transceiver? I don't understand this question. What do they mean by a group of stations?
Well, that's poorly worded.
It is, and the correct answer is supposedly C. But what identification code are they talking about? Okay, we're gonna have to research this one. This one bothers me. Question 10. This is an important one. Which of the following receiver filter bandwidths, we touched on that a couple questions ago, provides the best signal to noise ratio for single sideband reception? So the type of mode that you're trying to listen to, you can set a filter so that the radio listens to only a certain width bandwidth. And in this case, the answer is 2400 hertz. And this one you probably just have to remember, single sideband 2400. Because there's another question that asks about CW, and the answer is 500. So the only two right answers are either going to be 2400 for single sideband, or if it asks you about CW, the answer is 500. CW is much narrower. It doesn't need much bandwidth. So it's easy to remember that. Question 11. Which of the following must be programmed into a D-Star digital transceiver before transmitting? I played with D-Star. It's a little complicated. You definitely have to put your call sign in, because D-Star transmits your call sign every time you key up. It's automatically pushed through the system. DMR does not do that. That's one of the fundamental differences. D-Star is older, but in a way it's a little better because you don't even have to say your call sign. Okay, question 12. What is the result of tuning an FM receiver above or below a signal's frequency? You're going to hear some distortion on the audio because your radio isn't listening exactly to the right frequency. So the answer is D. Does it change audio pitch? I don't know what sideband inversion is. Generation of a heterodyne tone? No. It's going to distort the signal's audio. So you want to be right on frequency. Something in the chat. The answers are on the sheet. Thank you. I appreciate that. And that's it for T4A and T4B. Let's stop share. Questions? Anything need better explanation? I'm sure there are several things.
So Bill, we have time. Do you want to go back to T4A?
Yeah, let's do
And
that.
make sure that we cover all the answers
Yep.
that we didn't have right last time.
Excellent idea. Let's go back, share screen. Let's go to the top. The more you see these questions, the better you're going to do on the test. That's T3, T4A. Okay, now
I have a question about one of the B sections. For the filter bandwidths,
right.
When you set a filter, is it the width on either side of your frequency, or is it the total width?
I think both are correct. The frequency you're listening to is hopefully the center of that bandwidth. And so your radio is listening a little above and a little below that frequency. That's the total bandwidth. And so for single sideband, it's going to be a 2400 hertz wide. In other words, 1200 hertz above the frequency and 1200 below. So think of it as the thickness of a pipe. And then again, for CW, it's much narrower. Ideal is 500 hertz. Does that answer your question?
Yeah, I think so.
Cool, good. All right, let's go up to the A's. There was one I liked right off the bat. They get into numbers. Question 1, which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? Well, most radios that we use 13.8 volts. So you got two answers right off the bat that jump out at you. The correct answer is the higher amperage, 12 amps. If you multiply the voltage by the amps, you're going to get watts. So you're saying the power supply can handle about 140 watts. Your radio is going to push out 50. There's a certain amount of loss and heat, but you definitely do not want too small of a power supply. You want more than you need. Otherwise, the radio, as soon as you transmit, it'll probably lock up or shut off. And I've seen this happen. Okay, question 2. Which of the following should be considered when selecting an accessory SWR meter? Frequency and power level at which the measurements will be made. Well, that's obviously the answer A. But if we look at the other answers, distance that the meter is going to be located from the antenna, no. Types of modulation being used, doesn't matter. Answer is A, frequency and power level. In other words, if you're going to be putting out 1500 watts, you want an SWR meter that can handle that. Question 3. We did a little bit of this, but let's do it again. Why are short, heavy gauge wires used for a transceiver's DC power connection? To minimize voltage drop when transmitting, because that's when the radio uses the most power. You want it to be a fat pipe. You want it to get all the juice it needs so you can put out the signal you want to put. Question 4. We have not done this one. How are the transceiver audio input and output connected in a station configured to operate using FT8? FT8 is one of many digital modes. The answer is B, to the audio input and output of the computer running the appropriate software. Terminal program, terminal node controller, no. FT8 conversion unit. I'm not sure there is such a thing. And you don't convert it, connect it to the website. Correct answer, to the audio input and output of the computer, because you need a computer listening to the radio so that it is going to interpret the signals for you. Okay, question 5. Where should an RF power meter be installed? Answer is A, in the feed line. Just like the SWR meter, it goes between the radio and the antenna so it can see the power. How much power is your radio pushing out? Not the power supply output, not in parallel with any push to talk or antenna, in the power supply cable. No, those are all terribly wrong. In the feed line, the coax.
So a question about that.
Sure.
There are a number of items that are identified as being connected between the transmitter and the antenna. So it never goes into the relationship between them, like the meter and what's the one we were just talking
Oh, the
about?
SWR. So let's say you have
Yeah.
an RF meter and an SWR meter in
Right.
line. Yeah,
Right.
that probably is not going to help you get the best signal out. And you might want to do at least remove one of them temporarily.
Okay.
But that's a very good question. I don't operate enough HF, and to answer that. Steve, do you have any input on that? Hello, Steve or Ray.
Well, no, I was off researching that other question.
Oh, thank you. Thank you for doing that. So what happens if we got two things in line? Is that even a good idea? An
Well,
RF meter
No,
and an SWR?
your initial thing was correct, is that you get too many things attached and it's going to degrade your signal. You only need the power meter to check your radio. And then once you know what the power meter, say, hey, it's working, then that can be removed from that line. The only thing that you might want to consider having would be an auto tuner for the antenna. Leave that on all the time in case something went wrong, and that's going to save your radio. That doesn't really have to be there either if you've got a very good tuned antenna. So really, the fewer things, the better. I would recommend keeping the antenna tuner on there, though.
Yeah, I like it.
Unless your
Also-
radio does automatic antenna tuning internally, which a lot of them do.
Well, somewhere I read that a preamp between the radio and the antenna could be advisable. So now where would you put the next device? Would it be between the preamp and the antenna?
And the preamp is to increase incoming signals, right? It's to help your receiver be more sensitive. Do
I'm
I
not
understand what a
I'm not
preamp is for?
sure.
Because I don't think you need a preamp for transmitting. The radio itself is putting out a certain level, and then you might be running it through an amplifier to crank up the signal. So I'm not exactly sure what the preamp is going to be doing.
Okay. I guess I don't know enough to ask my questions.
Well, no, it's a good question, and I don't know a good answer for it. Steve,
Well,
do you have any?
for a technician license, that probably is a don't care.
That's true.
Because it's probably not going to be something you're going to have on the radio until you get an HF rig. And
Oh.
then, yes, if you want to increase sensitivity on the receive, a preamp is good. I don't know what the recommended order of connecting things is.
I think I
Okay.
have seen preamps for VHF and UHF. I can't recall ever seeing anything like that for HF.
I've got a preamp for VHF,
Okay,
and it's actually an internal to the radio.
so that
It's just an extra board that you install. So basically that's before way before it gets to the antenna.
So is that amplifying incoming signals or outgoing signals?
That's for incoming.
Okay, so it makes your receiver more sensitive then.
Yes.
Okay, thank you. That's very helpful. Okay, so we took care of 5. Let's go to question 6. What signals are used in a computer radio interface for digital mode operation? Oh, we did this one before. Answer is C. The 3 things the computer needs to have from the radio: needs to hear the audio, it needs to be able to put audio into the radio for outgoing, and it needs to be able to key the transmitter. Question 7. Which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? I do a lot of WinLink, so all of this is very comfortable for me. Well, computer line out to the transceiver push to talk? No. Line out means the audio. Line in, push to talk? No. Answer C. You want the input to the computer to be coming from the speaker output of the radio. It makes sense if you draw yourself a little diagram. Computer listening, that means the radio's got to be pushing audio toward the computer. Line out to the speaker, that wouldn't make any sense. That's audio coming out of the computer, bouncing against audio coming out of the radio. That doesn't make any sense. Answer is C. We talked about the flat copper strap already for the bonding at radio frequencies to make sure your radio is grounded to earth. That's a good question. Now, number 9, how can you determine the length of time that equipment can be powered from a certain battery? Well, it says the answer is B. Divide the battery amp hour rating by the average current draw of the equipment. So I use 32 amp hour AGM batteries a lot. That means you can draw 32 amps out of it for an hour, or a lot less than that for more hours. So if your radio tends to draw 4 amps when you're transmitting, let's say you're using high power, ideally that math should give you 8 hours. Realistically, as the battery's voltage drops, at a certain point, you have to stop using the battery. You cannot fully discharge the battery, you'll ruin it. But, and for this question, just do the simple math. You would say divide the battery's amp hour rating by the average current draw of what you got connected to it. B. Question 10. What function is performed with a transceiver and a digital mode hotspot? Going to be answer A. This is often used with DMR radios. People that can't reach a repeater might buy a DMR hotspot that connects to their local internet connection. I'm not a fan of this, especially for new users, because in my opinion, you're not learning radio. You're using the internet. It's a good thing to know how to work, because there's times when it might be useful where you do have an internet connection and you're trying to support people in an area that has no repeater. But from a learning standpoint, I don't recommend that people start fooling around with digital mode hotspots early in their ham learning. But the correct answer is A. Communication using digital voice or data systems via the internet, like a DMR radio. Question 11. We did this one. Where did the negative power return of a mobile transceiver be connected in a vehicle? At the 12-volt battery chassis, meaning the negative terminal on the battery. And if there's a chassis ground right there at the battery, that's acceptable too. Question 12. What is an electronic keyer? This is a way of sending code more efficiently, where you push it one way and it sends a dit, and you push it the other way, it sends a da, and it does them perfectly. So you can probably transmit really clean Morse more quickly and efficiently. Answer is C, a device that assists in manual sending of Morse code. Okay, we got us through the A's. We've done the B's. Any questions with this at this point? T4, A, and B. Everybody following along pretty well? Keeping up with this stuff?
I don't know about everyone else, but my greatest difficulty is that I'm using the ARRL book, and it's very hard for me to go from topic to topic. And I've sort of given up, and I'm just reading the book from the beginning on. And I just happen to be in chapter 4, which is the material you covered. And so it was good prep. But it's very difficult because the subject matter is scattered through the book, or vice versa. The topics, the way they are set up, have their order, and the book may not follow them that way. So it makes it difficult.
That's a very good point. You're absolutely right. Because we're limited on time in the way we're doing these classes, we pretty much are concentrating on preparing you for the test.
Yeah.
It's not ideal. Every question we encounter, there's background that we would like to give you. I'm trying to give you a little bit of that. We've got time to definitely explain some things better. I've tried to add a little local color, as it were, and experience. Steve's got a lot more of that than I do. But you raise an excellent point. The best books I've seen are where you can follow through the test prep, but every single question gives you a place to go look up more about that.
Mhm.
In the past, when I took my extra class, we used Gordon West's book, and he did that. He had a web link at every single question in the book. So if you were on your computer at the same time, you could look at a question. If you didn't understand it, you could type in that web link and go directly to a better explanation than just showing you the right answer. That's not enough. We want you to understand how things work and why these things matter. Straight memorization, you may get you through the test, but we also want you to be a great ham. Want you
Right.
to understand stuff and pass the test. And there's a lot we expect of you, including what you're doing, is doing your own reading and looking things up. That's excellent.
Okay, thanks.
Yeah, I didn't use the best resource today. I'm disappointed, and I'm going to write a note to the Wave Talkers folks because they are not up to date. They are not using the 2023 question pool. July 2022 is when it changed, and it looks like they have not incorporated some of the new questions yet. So I'm very glad Steve caught me on that.
So Bill, do you want to go back to that one question? Was it B09, I think?
Yeah, that was a beauty. Let's go back to that because we definitely have the time and we are very interested. Was it a B?
It was in B.
Okay.
I think it was like 9.
Okay. You guys can see it okay? Let's see. It's not being, oh yeah, that is it. Supposedly the correct answer is groups identification code. Have you found anything about this?
What was really interesting is I did a web search for DMR and group identification code. I could not come up with anything. So I think what they're referring to there is the DMR talk group.
I think so too.
But why they wouldn't just call it a talk group and use some other terminology that I can't find anybody using, I don't understand that part.
That's a nutty one. I'm going to search on the question just for fun. But you're absolutely right. As far as I know, in amateur radio, DMR is the only mode that uses talk groups. Have you pretty much found that to be true, Steve?
Well, it's all digital, but that's why they also have color codes,
Correct.
which,
But
which is
no other mode talks about talk groups. Talk groups
yeah, color
comes
codes
from
and
trunk
and time-
radio
yeah.
systems. But
Color
we're not
codes
actually
and-
doing that.
and time slots. So it gets really confusing. So just learn what you have to learn on this particular topic, and then get into if you're interested in DMR, get into it with your local radio club. That's my suggestion, because it is not easy when they start talking about code plugs.
Look what I just found on hamstudy.org. I clicked the little show me more on question B9,
I'm
and they're
not seeing
saying,
that. I'm seeing
Oh,
still seeing the
sorry.
questions.
let me fix it. I switched sharing on you. Let's, here
And
we
Mark-
go.
Mark G has his hand up too.
Yeah, hamstudy.org, they've got an explanation for every single question in study mode. So I went there and look what they say. There's some room for argument on this question. Yeah, we figured that out. The key here is digital voice, which it doesn't say. Well, I guess it does say digital voice, but it doesn't say DMR. But somebody put in a very nice explanation there. We should thank KD7 BBC, who was the last person to edit it. But they're not, even he's not talking about, or she is talking about DMR. And I'm pretty sure that this is a DMR question. Doesn't say anything about it. Group of stations. That one really throws me. So just remember, the correct answer is the group's identification code. And if you see it, you're just gonna have to squeak by. We don't have a good explanation, and we both think that this is worded badly. And I'm sorry, you said there was a question in chat.
Hand raised.
Go ahead, whoever raised your hand up.
Mark G.
Mark G, I'm not seeing hands. Oh, there it is. Yeah, Mark, I see a hand up. Are you here, Mark? Mark Guichard? Mark, are you here? Hand went down. Okay. Anybody else? Interesting section with a little bit of confusion here and there, including my own. Anybody have any other input or questions?
So Ray, I think you can stop recording now.
Yes, thanks.